In this video, we're going to talk about transcendental functions and viewing them as just examples of function notation. Sometimes students have trouble correctly interpreting complicated expressions, or for that matter, even relatively uncomplicated ones, such as sine of x cubed. I know this for a fact because many times I've heard a student read this as sine times x cubed. In calculus, this misunderstanding has drastic results. The student is seeing the expression as a product, calling for a product rule, instead of a composition of functions, calling for the chain rule. At its heart, this is a problem of not understanding function notation, of confusing f of x with f times x. Where does this confusion come from? Well, of course, we often use parentheses to designate multiplication. So how can we tell the difference? When does y open parenthesis x close parenthesis tell us to multiply y and x, and when does it mean that we have a function? Remember that multiplication is an operation performed on two numbers. Also remember that a variable such as x or y stands for a number. So if we know that x and y are variables, then y open parenthesis x close parenthesis is a multiplication statement, y times x. But if instead we're told that y is a function, a rule that is to be applied to its input, then this expression is function notation, and the value of this expression is the output we get when the rule y is applied to the input x. So in other words, we can tell the difference from the context. If we are told that we have a function, then we know we have function notation. Well, the transcendental functions are functions. The trig functions, sine of x, cosine of x, tan of x, secant of x, cosecant of x, cotangent of x, their corresponding inverse trig functions, the exponential and log functions, b to the x, e to the x, log base b of x, ln of x. These are all functions. Mathematicians, unfortunately, sometimes use a lot of shorthands. And usually with these functions, we don't put in the parentheses unless they're needed to avoid ambiguity. But wouldn't parentheses make it easier to see these as just particular instances of f of x if we put in parentheses after the function name and around the input variable expression? Of course, for the exponential functions, this is a little bit awkward, but many computer algebra systems will write e to the x instead as exponential of x. And I guess the b to the x, we could sort of adapt a hybrid expression like exponential base b of x. That'd be very consistent with how we write logs. And it would be easier to see these as being function notation. It would help us a lot if we could remember to always read trig, inverse trig, and log functions with the word of. Sine of pi over 2, for example. Or log of 1,000, for another example. This would avoid us making the beginner's mistake that is shown here. The question is, solve sine x equals 1. So the student, the beginner student, starts by multiplying both sides by 1 over sine. The signs cancel out, and we get our solution as x equals 1 over sine. If we read this as sine of x equals 1, this clearly makes no sense. We can't divide by 1, but we can't divide by sine of. Sine of isn't a number. 1 over sine of makes no sense. This would be like solving square root of x equals 3 by dividing both sides by square root of, or multiplying both sides by 1 over square root of, and then canceling out the square root ofs to get x equals 3 over square root of. Nobody makes that mistake, but lots of students make the mistake with the other transcendental functions. I hope that helps clear up this confusion and helps you develop some sound habits, like putting in the parentheses and reading transcendental functions correctly with the word of in there, to keep you from confusing it with multiplication.